So today we are going to take the topic of energy balance, chapter 7, page number 126. Those who have the new textbook, please mention the new page numbers in the chat box as well. So we'll start with today's chapter. If anyone is joining late, please help them out with the page numbers and chapter name or topic name. So energy balance. Energy, what do you mean by energy? It is basically your ability to work. Okay, whatever movements you do, willingly and unknowingly, that your voluntary actions, your involuntary actions, even your breathing, respiration, that also consumes energy. Okay, your resting body metabolism consumes energy. Digestion, which is not under your control, still consumes energy. So the ability to do work willingly, unknowingly, both requires energy. Okay. So the energy which is contained within the food, macronutrients, carbohydrates, proteins, and fat. Okay, these are the macronutrients that provide energy to your body on a daily basis via food. Vitamins, water. Am I audible now? Is my screen visible? Okay. So, how does the body utilize oxygen and give out energy when oxygen is in union with carbon dioxide and hydrogen? Okay, they form carbon dioxide and water. Okay, when oxygen combines with carbon ions that are already present, every part of your body, every cell of your body has carbon ions. Okay, and when oxygen and carbon they combine, carbon dioxide is formed, and when oxygen and hydrogen elements are combined, water is formed. Okay, and during this combination, heat is produced. This heat is what we call as energy. Okay, so kilocalories is what we use as a unit of measurement for energy, KCL, kilocalories. Okay, so this is the biological system that of energy is measured in kilocalories. In some cases, kilojoules is also used, but kilojoules is used for higher efficiencies. Okay, but for basic diet requirements, diet plan, kilocalories is more than enough to use. Okay, so that is a definition of kilocalorie. 1 kilocalorie is the amount of heat energy needed to raise 1 kg of water at 1 degree Celsius at 15 degree Celsius. For example, when you hear this definition for the first time, it will be very confusing for you. But imagine a situation, you are given 1 kg of water. You can convert 1 kg into liters. You will understand how much liters it would be. So you want to raise the temperature of this 1 kg of water just by 1 degree Celsius. Let's imagine the water given to you was at 14 degrees Celsius. Okay. You just want to raise the temperature of this 1 kg water into 15 degrees Celsius. By 1 degree Celsius, you want to make the difference. That 1 degree Celsius increase you want to achieve. So the amount of heat required, okay, the amount of heat required to raise this 1 degree Celsius temperature of 1 kg water, that amount of heat is what we call as 1 kilocalorie. Is it clear to all? Is the definition clear to all? What do you mean by KCL, or what exactly is KCL? Is it clear to all? Yeah. So 1 kg of water, 1 kg of water, okay. Just check in the Google what exactly is 1 kg of water in liters. Anyone just check in Google what is 1 kg of water in liters. You can put in the chat box. For water, it will be, yeah, it will be approximately 1 liter. It is not exactly 1 liter. If you are using other forms of liquids, there are certain changes. Okay, it is approximately 1 liter. Okay, so 1 kg of water, we can approximately take it as 1 liter of water. When you want to, and you are given, let's say, a 1 liter of water at a temperature of 14 degrees Celsius, 14 degrees Celsius. You have to increase the temperature of the water just by 1 degree Celsius and achieve 15 degrees Celsius. 1 5, just 1 degree increase you want to achieve in Celsius. Okay. So the amount of heat required to achieve this 1 degree change, increase of 1 degree change in the 1 liter of water, that amount of energy is what we call as 1 kilocalorie. Okay. Is it clear now? So there are other ways through which also you can check energy that is released. Calorimetry is one such technique. These calorimetries are used only in laboratory settings, okay, in research settings where, and specifically in sports also, when you want to check the performance of athletes, okay, what is their endurance, how much energy they are burning, okay. In this case also calorimetries are used, okay. For regular users, for a dietitian, for a nutritionist, you just have to know what calorimetry is. You don't have to use it, okay. Only in a laboratory settings, in a biological settings, these researches are done. So the amount of energy that is being released by an individual can be obtained by direct or indirect calorimetry. Okay, so calorimetry is a technique. I'll show you the images of those as well. Okay, so indirect calorimetry, what you do is you check the amount of food stuff, whatever food, rich in carbohydrate, protein, lipid. Okay, that amount of food, when oxidation takes place for that food, that is burning, when these macronutrients are burnt in your body, metabolized in your body, okay, it will give you heat, carbon dioxide, and water. So indirect calorimetry, we are checking the amount of uh, oxygen and carbon dioxide which is released. Okay, also the heat that is released, that is what we check in indirect calorimetry. Okay, we are seeing how internally a person is able to burn this calorie. But in direct calorimetry, we don't check what food was given or how much heat or carbon dioxide or water is released or sweat is released, because when you digest food, okay, when you digest food, your body produces heat, your body perspires, okay, so sweat is also coming out in the form of water, in the form of urine, in the form of feces. Your body leaves, the water is leaving your body. Carbon dioxide is also released. It is released through your lungs. Okay. So when energy is produced, heat is produced, carbon dioxide is released, water is also released. Okay. And this heat that the body releases, that is what we check in direct calorimetry. Okay. That is the main difference between indirect and direct. In direct calorimetry, the person is put on into a system into which they have to breathe in while they're cycling or while they're running. I'll show you the image of that, how they do it for athletes. Okay. So this is an indirect calorimetry. It is used in laboratory. We do not do any human test on this. You will only burn specific food items which is rich in carbohydrates, proteins, lipids, or fat. Okay, you put some specific type of oil and see how much calories you're burning over a period of time, which oil is better. Okay, and carbon dioxide, which carbon dioxide rich food, different kind of food is put into this indirect calorimetry. It is burned, and when the burning takes place, the amount of energy released is calculated. Okay, it is done only in a laboratory setting. This is direct calorimetry. You can see here how a person is attached to specific systems in which he or she has to breathe into. Okay, and the amount of oxygen taken in, the carbon dioxide release, and the heat that the body is releasing also is warm. There is a heat in it. Okay, so based on that, it is understood how much calories this person is burning while doing a specific activity, cycling for 1 hour, cycling for half an hour, running for half an hour, or something like that. Usually they do this on cycling. Okay, so this is an example of a direct calorimetry. Directly, you're seeing it on a human. On a human, you will experiment how much energy this person is burning. What is the endurance of this person? Okay. So that is about calorimetry. Only this much you have to learn about calorimetry. There are different types of calorimetry equipment used per purpose. Okay, these are given in the textbook on table 7.1. Equipment used in direct and indirect calorimetry. Sweat is not mentioned. Sweat we are not checking. Okay, we are just, if you remember this, heat. Okay, heat and the amount of carbon dioxide released is what we directly check in direct calorimetry. Okay. Sweat, how we check is there is a specific formula for that. Before you do an exercise, what is your body weight, and after you do an exercise, what is the body weight? The difference, there is definitely a difference, because after doing a specific exercise, you sweat a lot. Your weight will reduce a bit. There is a difference. That small, based on that small difference, a formula is used on based on which we will know how much sweat loss or water loss you have achieved in this particular session. Okay, students who are doing sports nutrition, for them this topic has come under. Okay, the formula for checking the water loss and sweat loss. Coming to the physiological value of food, which means when you are burning any food item within the body, how much calories do you expect to produce? Okay, first is proteins. 1 gram of protein can give you 4 kilocalories of energy. Carbohydrates again will give you same 4 kilocalories of energy. 1 gram of carbohydrate can give you 4 kilocalories. Fat, 1 gram of fat can give you 9 kilocalories. And alcohol will also give you energy. One gram of alcohol can give you 7 kilocalories of energy. It's not mentioned here, but alcohol is also supposed to give out energy. Okay, but the values which we take here, 4, and 9, this is what we consider that the amount of energy that these macronutrients give within a human body during metabolism. There is one catch to it. If you are doing this externally, outside the human environment, outside the human body, the energy given out is slightly higher. Okay. For example, you can check the textbook on page number 130. Those who have the textbook, page number 130. There's a table given. The calculated physiological fuel of nutrients allowing for losses in kilocalories per gram. So there you can see exactly how much of energy or kilocalories you will get by burning these macronutrients, which is slightly higher. In decimals, it is slightly higher than the regular burning of regular burning of calories. Am I audible now? Is my voice clear? Am I audible? If my voice is breaking, please mention in the chat box. Yeah. So I was mentioning these physiological fuel value which you see here on screen is what we consider that they gave give inside the human body. But when you try to burn proteins, carbohydrates, and fats outside the human body, it will give you slightly higher kilocalories. Okay. For example, if you are burning proteins outside the human body in a laboratory, if you're testing the amount of protein, how much calories you will get from this source of food, of this protein rich source of food, okay, that can give you around 5.65 kilocalories per gram outside the human body. But within the human body, proteins can give you only 4 kilocalories. Outside the human body, carbohydrates can give you around 4.15, slightly higher amount of calories as compared to within the human body. In case of fats, almost 9.45 kilocalories can be burnt outside, but inside the body, it is just 9 kilocalories. Okay, this is owing to the fact that whatever food you eat, a slightest amount of food is taken, is not absorbed by the digestive system. Okay, it is lost as it is, as a process of digestion. So some amount of food is lost as it is. So owing to that fact, we just consider these specific targets as a physiological fuel value. Is it clear now? Physiological fuel value and heat of combustion is the main difference here. Heat of combustion is what you do outside the human body when you are checking if you oxidize this particular type of food, this particular source of food, how much calories you will get. Okay, but within the human body, systems are slightly different. You have to consider certain amount of food that will be lost in digestion. Okay. Coming to the components of metabolism, in the textbook, there are various topics on different kind of calorimeter. Okay, you don't have to study about it. For example, Benedict's calorimeter, relation between oxygen required and calorimeter value. These things are not important from your point of view. Okay, these are too technical. Okay, these kind of knowledge has to be required by person who is doing food and nutrition experiments in a research lab, in a food technology lab. Okay, for them, these kind of calorimeter knowledge is important. But for practicing dietitians and nutritionists, okay, in detail about calorimeters is not required. Coming to components of energy expenditure, am I audible now? Yeah, coefficient of energy expenditure is much more, what to say, it's a technical part, okay, in which a specific amount of energy is given and how much is utilized. Okay, the ratio of that supplied energy and utilized energy, that is what coefficient of energy expenditure is. For example, you are given 500 kilocalories in a form of food item. Okay, and how much are you going to burn? Okay, that is another. How much are you going to utilize? That is another way of saying it. Coming to the components of energy expenditure, this also is a part of coefficient of energy expenditure. Okay, how much calories you feed yourself, how much are you actually burning? Okay, so which from the pie chart here, you can see resting metabolism, or it is basal BMR, basal body metabolism rate. Okay, which means even when you're sleeping, when you're not doing anything, you're resting. Okay, you're not doing any physical activity, your body is still burning energy. Okay, but your body is still burning calories. Okay, that is resting body metabolism. You can see here on the pie chart, around about approximately 60-65% of energy expenditure is just because of your resting body metabolism. Okay, it is on page number 132. So that is resting body metabolism. When you're not doing anything, even when you're sitting, sleeping, resting, your body still consumes energy in form of digestion, in form of breathing, in form of all the involuntary movements that the body does. Uh, Energy is consumed and as energy expenditure does take place. Okay. Next is your physical activity. Next big chunk goes to the physical activity, approximately 32%. In the textbook, they have given 25 to 30%. It's approximately 32% of body expenditure that takes place because of physical activities, and this changes from individual to individual. Okay, the physical activity changes from individual to individual. It completely depends on what kind of lifestyle you have, sedentary, moderate, is active or active. And next 8% is the thermic effect of food. Every food has a specific thermic effect. Some food bring more heat energy into the body, and because of which energy expenditure increases. Some food have cooling effect, so they will reduce your energy expenditure. Okay, we will discuss about the thermic expenditure of food in a bit. So is the pie chart clear to all? This is just a generalized statement, but always remember, for everyone, whatever is your activity level, sedentary, moderately active, or active, whatever is your activity level, always your basal metabolic rate. For everyone, your resting metabolism, your basal body metabolic rate, BMR, is the one that is going to consume the majority of your energy. Okay. And for people who are looking for weight loss, why we talk about building more lean muscle. Okay, to maintain the lean muscle, maintenance of lean muscle itself is another task for your body, to which calories has to be burnt. Okay, so maintaining the lean muscle, another is also another task for your for a human body, and which comes in part of your resting metabolism. So having more lean muscles means that, automatically means that, your resting metabolism is definitely high. Your basic metabolic rate is definitely high. Okay, so to maintain that, if you work on building more lean muscles, okay, even after weight loss, first you have to achieve weight loss, then simultaneously or after that you can build more lean muscles. Okay, so that will keep your resting metabolism high. But when you're doing some crash diet, for example, some 10 days starvation diet, some crash diet you are doing, what will happen to your resting metabolism? Any idea? You do some crash diet or some severe starving diet, it will fall down. Your resting metabolism will fall down. Okay, your body does not have enough heat energy to burn. Okay, with limited energy it is functioning, so the body does not require too much of resting metabolic energy. Okay, so your resting metabolism falls down when you do some crash diet. And when you when the time period of the crash diet is over, when you go back to normal, okay, you have increased the calorie intake, but the body is not yet ready to accept that increased calorie intake. It is still in the slow resting metabolism rate. Okay, it is burning energy is very slow. The supply is high, the expenditure is quite less. That's how you put on weight. You double the weight that you put on after some crash diets and all. It's doubling. Reason being, doing crash diets, putting your body through starvations, you have brought down the resting metabolism so down that when you're feeding yourself regular meal, that itself your body consumes, the body will think of that as high energy, and expenditure is not done. So there are certain tips that you have to remember, to which you can increase your resting body metabolism. Okay, it is important that you keep your body alive, healthy, and physical activity should be inculcated on a regular basis. So that will keep your metabolic rate high. And try to indulge more of muscle movements in your day-to-day activities, even if you're doing regular household chores. Okay, add more muscle movements. Okay, don't for example, don't just stand and do the kitchen chores. Whoever you like, men and women both. Okay, if you're spending some time in kitchen, try to move you at least your legs to and fro. Okay, you can just be on the heels and come down like that. Involve your muscles in more and more movement, because of which muscles are built, lean muscles are built, and that will increase your resting metabolism. Okay. Coming to the BMR rate, basal metabolic rate, it's on page number 133, those who have the textbook. This is the amount of energy required to carry out your involuntary work. For example, the work that for which you do not require any, you do not require your physical mind to say you to do it. For example, the heart, which is beating, okay, it is doing its work. It requires energy as well. Okay, your thought process, your mental functioning, your cognitive thinking also requires energy. Your brain requires energy. Okay, breathing, digestion, peristalsis movement, whatever involuntary things takes place within a human body. Okay, everything is based on energy. So basal metabolic rate covers that. It includes the function of various activities of your organs such as brain, heart, liver, kidney, lungs. Okay, even the secretion of hormones from your glands. Energy is required. Peristaltic movement. Peristaltic movement means the wave-like energy that takes the wave-like movement that begins at your esophagus and ends at your anus as a part of the digestion. Okay, that is peristaltic movement. Oxidation that occurs within the tissue. Okay, within the cell, within, even when you're sleeping, oxidation is taking place. Your cells are using up energy, burning the energy is taking place. Maintaining your muscle tone, those specifically people who have uh, more lean muscles. Okay, to maintain that muscle tone, that also comes under basal metabolic rate. And the body temperature, to maintain the body temperature as well, that is also part of the basal metabolic rate. So all these activities come under the basal metabolic rate, and men have a higher BMR as compared to women. Okay, in any age group, take any age group, men will always have a higher BMR as compared to women, because men naturally have high lean muscle as compared to women. Okay, women more have the adiposity. Adiposity in women is higher as compared to men. Men have more lean muscle as compared to women. This is one of the reasons why men have higher BMR. Even if you take the same age group, men of that age group or males in that particular age group will definitely have higher BMR as compared to women. So this formula that you see on screen, this is the BMR formula for men and women. Okay, there is a slight difference. In men, you have to add 5 at the end. In women, you have to subtract 161 at the end. Remaining all the other factors will be the same in this formula. First, this BMR formula, you have to memorize it, not for the exam purpose, but for your practical purpose, because based on this BMR formula, you have to make the diet plans, menu plans. Okay. It's a St. John, St. George and Mifflin formula, the BMR formula. Reason I have mentioned, men have higher lean muscles, women have lower amount of lean muscles as compared to men. Women have more adiposity, men have less adiposity. These are the reasons based on which men have a slightly different formula and women have different formula. Okay. The physiological composition, the physiological functioning and composition of men and women are different, inherently different. Okay. So when you are doing this formula, please remember the mode mass. Please remember the BODMAS, which is B stands for brackets, O for operations, okay, D for divisions, M for multiplication, A for additions, and S for subtractions. Okay, this is the value that you have to follow. This is the order that you have to follow while you're using this formula. So when you're doing this formula, first try to solve what is in the brackets. BODMAS means first you have to solve the brackets and then move on to addition and then subtraction. So first you have to solve what is 4.536 into weight. Keep that number aside. 15.88 into height in inches. And when you convert into centimeters, the formula will change. Okay. So you have to check you have to solve the bracket first, then 5 into age, keep that number aside, and then add all the first bracket, second bracket, third bracket, plus, first bracket, second bracket, plus 5 in male's formula. Okay, whatever answer you get minus the third bracket. This is what you have to follow. LBS means pounds. Like how we use kilograms in India, pounds are used in UK, US, etc. Kilograms is used in India. Even in UK, I guess they still use kilograms more than pounds. Pounds is more used in USA. Canada and USA, they use pounds. It's again a unit of measurement. B in BODMAS stands for brackets. O stands for operations, like square root, cube root, something like that. Okay, that is operations. D stands for divisions, M for multiplication, A for addition, and last comes the subtraction. So this order you have to follow. Otherwise, everyone will get a different answer. If you do not follow the BODMAS, when I give you a problem to solve, everyone will get a different answer. You can just Google it. 5 pound is equal to how much kg on, you will get it online. There is a formula for that also. Yeah, thank you, Adrit Sharma. He has mentioned 1 kg is equals to 2.204 pounds. Okay, just do the cross multiplication, you will find the answer. In kgs also, St. John and Mifflin formula is there in kgs as well. When we will take a chapter on obesity, diet and obesity, we'll discuss that in detail. This formula which you have mentioned is used when weight is in kilograms, height is in centimeters. But when weight is in pounds, height is in inches, this is the formula which you see on screen. This has to be used. I mentioned earlier, when you use kilograms or centimeters, formula will change. So the formula which Laborie Jishant has mentioned, that is used when you are using kilograms and centimeters in the formula. Okay, but when you're using pounds and inches, use the one which is mentioned on screen. So is it clear to all how to use this formula? Because using this formula, this we have noticed with various other batches as well. When we give we will solve an issue regarding this as well. On live, we will solve a problem. So in the live solution, when majority of the students are getting different answer, reason being they forget the BODMAS. They forget the order of solving the problem. Okay. Now, what Jishant has mentioned is only half the formula. What Jishant has mentioned is only half the formula. The first half, which is same for men and women, only that he has mentioned. Plus 5 that is added and minus 161 is that remains the same in the other formula as well. The formula in which you will use kilograms and centimeter, even in that, this difference is there. Plus 5 for men, minus 161 for women. This difference is there in the other formula as well. So this is how you calculate a person's body mass index. A person's weight is important, their height, their age, okay, and their gender. Their sex is important. So these four elements are important to calculate a person's basal metabolic rate. Then we have the physical activity ratio. Again, they have given in detail about direct calorimetry, indirect calorimetry, not required from exam point of view and as well as for your particular knowledge. In this detail, it is not required, okay? We can directly come to the physical activity ratio, which is on page number 138. Those who have the textbook, move to page number 138. So any idea why physical activity ratio would be important? Why not just the basal at metabolic rate? Basal metabolic rate is very simple. Okay, a person's age, height, their gender, their sex, and their weight. Okay, these things are important. Okay, but what is the importance of physical activity ratio? Can BMR be used for everyone? This one formula can be used for everyone worldwide. Yeah, physical activity ratio is not used to count the calories burnt. Physical activity ratio is used to see how much calorie is required. Do you understand the difference between it? Basal metabolic rate is used to understand how much calories is burnt. BMR is used to understand how much calories is burnt. Physical activity ratio is required to understand how much calories is required. Which means with the BMR, you know exactly how much this person is burning, even when they are resting, when they are not doing anything, when they are resting. How much is this person burning? That we understand by BMR. Okay, the formula that I have shown you. But when we introduce physical activity level or ratio into the BMR, that's when you get the answer. How much calories should I suggest this person? What should be the maintenance calories for this person? What should be the weight reduction calories for person A? Okay, what should be the weight gaining calories for person B? What should be the weight maintenance calories for person C? Everyone has a different goal when it comes to food and calories. Some people want to lose weight, some want to gain weight, some just want to just maintain that weight. They're in an ideal BMI, they just want to maintain that. Okay, so for everyone, these three different segments of people, okay, physical activity ratio comes into play when you are good as a dietitian or as a nutritionist. You are going to sit down and calculate how much calories you should give this individual. Okay, as a calories, don't get stuck behind calories. I'm repeating that. Don't get stuck behind calories. The importance should be portions. Portions should be the first priority. Calories is just a broader outline. Okay, for example, if I say, generally I'll say a 25-year-old female, moderately active lifestyle, okay, 200 kilocalories she has to have. When I say 200 kilocalories, does it mean that she has to definitely inclusively stick to that 2000 kilocalories? Sorry, 2000 kilocalories. Does it mean that she has to be inclusively within that 2000 kilocalories only? She can go 100 kilocalories up, 200 kilocalories below. She can be in a range. Okay. So you have to focus on the range of calories that you are taking on a daily basis, which comes by the understanding of portion size. The first few days, you can stick on the kilocalories. First 1 week, you can stick by the kilocalories what your dietitian has suggested. Okay. But later you will understand the portion size. Your body will become used to the portion size you are eating. then your focus should be on the portion size. Your focus should not be on the calories, because that will create a negative uh, body and health nutrition image relation. Okay. So coming to the physical activity ratio, it's a ratio, means it's a formula. Energy cost of an activity per minute divided by energy cost by the of BMR per minute. How much energy will you burn by doing an activity for 1 minute divided by how much energy you are burning automatically because of your BMR. Everyone has, every living breathing organism, every living breathing person has a BMR. Per minute, some amount of energy they are definitely burning. Okay, so that is the denominator. Numerator is pick any of this activity. Okay, let's say washing. Pick any, washing is one activity. So when you wash something for 1 minute, how much energy you are going to burn? Okay, that you will put in the numerator and divided by energy cost of BMR of that particular person per minute. Okay, this is the physical activity ratio, not used in general practice. Okay, general practice it is not used, just for your understanding, just to give you the meaning of what this ratio is, physical activity ratio is. Okay, just to give you an understanding, we are explaining it here. So online you can search what is the physical activity ratio for cooking, dancing, Bharatnatyam, okay, or whatever you're doing, okay, running, surfing, paragliding, okay, whatever activity you choose. Okay, every activity has a energy cost. Every activity has an energy cost. For 1 minute, how much energy you are burning by doing that particular activity? That is a numerator. Divided by 1 minute, how much is your BMR? Okay. For every activity you will have to add, for every activity like homework, washing, you have to, every activity you have to add and take the average of it, or just as take a summation of it. On average, how much this person is burning, or on average what is the physical activity happening for this person, you can understand that. For example, slow walking. Okay, slow walking, you can see the physical activity ratio is around 2.5. Okay, so it is somewhere around 2.5. So this 2.5 will be used in another formula, which we call as physical activity level. Okay. See, just for example, the basal metabolic rate of person A is, let's say, 800 kilocalories. The basal metabolic rate for this person is 800 kilocalories. Okay. When I say this term 800 kilocalories, is it for 1 hour, 1 day, 1 week, 1 month? What do you think? When I say basal metabolic rate, and 1 day will have how many minutes? One day will have how many minutes? One hour has 60 minutes. 24 hours has 1,440 minutes. Okay. Now you understand how you can convert the BMR into per minute. When I say 800 kilocalories for entire 1,440 minutes. Okay. So if you want to convert it into 1 minute, you will know the cross multiplication, right? So is it clear how you can calculate the BMR per minute? Understood the technique here? Okay. So physical activity ratio, you will understand based on this particular formula. But for everything, first you have to identify what is the BMR. Okay. Convert the BMR into 1 minute. You will get an answer. Convert the BMR into 1 minute, you will get an answer. Keep that answer aside, and then you will find the cost of activity per minute. Okay. What activity they are doing, and per minute how much energy they are burning. Okay. For example, brisk walking for 1 minute, how much calories you will burn. Just search it in Google, you will get an answer. Okay. You have to put that in the numerator. But for your advantage, physical activity ratios are already given. Okay. People have done research on this. People have done tracking on this. Physical activity ratio, this chart which you see here, the graph which you see here, this is already built. Various articles, various sites have built this PAR ratio. Okay, PAR is already present for various activities that a human does. Okay, as a part of their physical activity, it is already present. So you don't have to sit and calculate this. I'm just giving you how people came into the calculation of this. Okay, you don't have to sit and calculate the BMR per minute, what this person is doing. You don't have to calculate that. Okay, because the PAR is already present. It is inbuilt. It is already present. So take any network website. Okay, just Google it. Okay, the PAR for washing, PAR of dance, PAR of running. Okay, just search it. Okay, you will get the answer. So you will get the PAR. I'll come to that. Okay, I'll come to that. Because if the person is doing swimming, cycling, lifting, okay, what do you think is the physical activity level? Physical activity level you can see here. The answer already you know what is the physical activity. If a person is doing swimming, cycling, lifting, everything in the same day, you don't even have to calculate all these things that I have said from the options given here on the left. Imagine a person is doing swimming, cycling, lifting, everything they are doing on the same day. What will be the answer here? Is it sedentary? Is the person sedentary, low active, active, or very active? Very active, right? So based on the gender of the person, you can select which level you have to, which number you have to use, right? You don't have to worry about the PAR, how to add the cumulative value and make it into PAL. You don't have to. You just have to ask your clients what kind of activities you do. They give you a list of activities. These are the things, 3 to 5 hours every day I dedicate for these many trainings. Automatically, this person is a very active person. They have a very active lifestyle. So based on their gender, based on their sex, you have to identify what kind of physical activity you will put, what number you will put, because this PAL number comes in the formula which you will require to calculate the calories to be given to this particular client. Okay, so why PAR? You have to study about PAR, this formula. The reason being, only using this PAR, you can come to the PAL value. That is done scientifically. Okay, but if you can extract the details from your client, what kind of activities they do. They say if they're not doing any activity, they are in a work from home situation, they're not doing any activity. Okay, hardly they do the household chores. That also with the help of maid or with the help of electronics, they are doing a household chores. Definitely, it's a sedentary lifestyle. Without the help of any maid or aid, from morning 6 a.m. to 12 p.m. Most of the housewives or homemakers in India, okay, they come under the low active lifestyle. Okay, if 6 to 12 they are doing their household chores, kitchen chores, sitting and doing, relaxing and doing, it's a low active lifestyle. It's not an active lifestyle. Okay. So based on these details, you have to extract the information from your client, and then you put a physical activity level for them. Is it clear to all? So you don't have to worry about the PAR. PAR is used just to come or arrive to a conclusion of physical activity level. Because when we see the physical activity level formula, how can you find the physical activity formula? The numerator should have the total PAR hours. For example, somebody told now that if a person is doing swimming, cycling, lifting, okay, so PAR for swimming plus PAR for cycling plus PAR for lifting, PAR for any other kitchen chores or something, everything plus 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 is the total. The total PAR will be on the numerator. Denominator, it will have the total time. For example, 24 hours, the entire 24 hours, what you're doing, or the first 12 hours of the day, what you're doing. But usually we take it as 24 hours, the whole day, what all things the person does, it is put into 24 hours section. And this hour, morning 6 to 7, this is what the person does, what is the PAR. 7 to 8, they go for brisk walking, what is the PAR, plus, plus, plus. So that all this plus, plus will come in the numerator, and the denominator is the time. Usually it is 24 hours. That's how you come to the physical activity level. Okay, is it clear how you can come to physical activity level from PAR? The difference between PAR and PAL. PAR is physical activity ratio. PAL is physical activity level. Is it clear to all? If you have any queries, please ask. I can explain it again. See, PAR is the physical activity ratio. You don't have to calculate PAR. Okay, no need to calculate PAR. Just the formula, I have explained it just for the sake of explanation. Okay, PAR, this formula that you see on the left side, energy cost of an activity per minute divided by energy cost of DMR per minute. This thing you don't have to calculate, because PAR, just search for it. Okay, just give me any example of activity which is not given here. Any activity which is not given in the graph. What comes to your mind as an activity, but it is not given in this graph? Yeah, for energy cost or physical activity ratio for karate, somebody has mentioned karate first. So for karate, it's around judo karate, it will be around 5.2. I just Googled it. I just took physical activity ratio for karate. I just Googled it. I got the answer. It is around 5.2. Okay. Similarly, whatever activity the person does, if it is not given in the list or whatever list you prefer, this is just a random list that I took from online. Okay, you can just search about physical activity ratio or PAR list. Just find a list and keep the list which has maximum number of activities, go with that. And if there is a specific activity that the client says that they do, it is not available in the list, just find out a similar activity. For example, somebody told karate, I could not find exact karate, but I went with judo, right? Almost the same. Is it clear to all how to get PAR? if you find some drastic BMR, okay, this BMR, the physical activity ratios which you get in these kind of sites, okay, it is based on, for example, how we say 2000 kilocalories is the specific diet required for a sedentary lifestyle person, an adult who is in a sedentary lifestyle. We generally say, right, 2000 kilocalories is required. On the same part is what we use PAR as well. It's a generalization that taking that general a healthy adult's body ratio, the healthy adult's BMR ratio, and based on that, if they do this activity, this is what they are burning. Okay. But if you want to be very specific about your client, then you will have to do the PAR formula also. You will have to find energy cost of karate per minute. If you do karate for 1 minute, how much is the energy that you're burning? Okay, you have to find that based on the person's details, BMR details, you will find the BMR. Okay, you have your physical activity ratio. If you want to be that personalized, okay, is it clear now? Formulas, choice of right and wrong formulas can be asked in exam. You will have to select the correct formula. That can happen. Physical activity ratio, this ratio along with some other ratios will be given. You will have to identify which is the right ratio. Okay. So PAR, is it clear to all what is PAR? How can you come to a conclusion with PAR? So the person who is doing karate, he may do dance also. He or she may do some swimming also. Okay, yoga also, cooking. Okay, this person is living alone, they're doing cooking, they're doing their household chores, they're doing their karate, they're doing their work. Okay, they're traveling, transport, okay, by bus, by a car. Okay, transport is also given on this list. Okay, slow walking, fast walking, how long they have to walk for from this point to point B to get to their work. Okay, based on that, you add everything on the numerator divided by 24. You will get the physical activity level. Okay, so anyone whose physical activity level is between like 1 to 1.39, they come under sedentary. When you do the calculations, if you don't have to do it, because if you know the if you have an idea, you just have to use your common sense here. Just see, ask the client questions. How many hours they spent on workout? Okay, let's say a person says, I spent 1 hour walking. Okay, a client says, I spent 1 hour walking. What do you think? Where do you put them in this physical activity level? And they don't do any other work. They are doing work from home. 1 hour they are walking. Okay, they do work from home, or they are a homemaker. It's low active. It is low active. Okay, walking. If you're spending at least 1 hour for walking, it does not become sedentary. Okay. And for example, if a person says, I go to gym for 2 hours and I commute to my office as well. Okay, I don't work from home. I have to travel for at least 1 hour to and fro to commute to my office, and I do my cooking. I do the household chores, and out of all this, I spend at least 2 hours to go to gym. Where do you put this person? They come under very active. Okay, even though they are just spending 2 hours in gym, but looking at the other components of their lifestyle, the lifestyle matters. Okay, the lifestyle matters here. So looking at the other components of their lifestyle, you put them under very active category. Okay, if the person is just doing 2 hours of gym, 2 hours of gym, and it is a work from home situation, it is an active, and they have that maid assistants to take care of other chores. Okay, it's an active situation. So is it clear what kind of questions you have to ask and where do you categorize your client? Is it clear to all? Did you understand how do you come to physical activity? How did you come to the physical activity conclusion from PAR? How PAR will lead you to physical activity level? Okay, so we'll move forward. So yeah, you have to remember this while calculating the calories, because you have to multiply the physical activity level into the whatever BMR you have found here. Whatever BMR you find here in this formula, you have to multiply the physical activity level you find for your client. That is the calorie. That is the calorie requirement. Okay, and that is the calorie maintenance. We can say it's not requirement, calorie maintenance. But if their focus is on weight loss, you have to minus at least 500. If their focus is on weight gain, you have to add 500. Okay, we'll see that later with the diet and obesity classes. We'll discuss that later. Okay, because we will do this with an example. We will do this entire formula in diet and obesity class in future. Okay. But for right now, I guess you all know your own age, height, weight, your activity level. At personal level, you all know that. You can at least find your own calorie requirement. Whatever calories you get, okay, based on your personal choice. If you are somebody who wants to lose weight, okay, so physical activity level multiplied by BMR. I'm putting in the chat box so that you won't confuse. So BMR formula based on your, if you're a male or a female, BMR formula multiplied by what you get from BMR multiplied by physical activity level. Now, whatever is your physical activity level based on your individual lifestyle. Okay, put yourself consciously in whatever lifestyle you come under. Again, based on your gender, man or woman. Okay, multiply the PAL into the BMR. You will get the calorie maintenance. If you are happy with where you are in terms of your weight, in terms of your health, in terms of your BMI, if you're happy with where you are, your task will just end here, BMR into PAL. But what if you want to reduce your weight? What can be done from this formula? What if your task is to reduce weight? What can be done from this formula? Yeah, approximately 500 kilocalories has to be reduced, but not immediately, right? If a client comes to you today, he or she is having 2,500 kilocalories on a daily basis, on an average basis. They want to achieve weight loss, okay? And immediately you can't tell them to cut 500 kilocalories from next day onwards. You have to slowly push them into it. Okay, week 1, just cut 200 kilocalories. Week 3, by week 3, 400, and by the 5th week, 500 kilocalories, cut it out. Okay, it's like slowly you have to taper the calories less by less. Okay. And also, if somebody wants to, let's say, if somebody wants to gain weight, BMR into PAL, then what you will do if somebody wants to gain weight? Yes, add 500 kilocalories. Okay. So is it clear to all how to make a boundary of calories, personalized boundary of calories based on the client's activity, their lifestyle, their height, weight, age, etc. We have covered all the basic aspects which maintains a person's weight. Okay, by doing this. How much calories is required by a person in a day? We cannot say that because it completely depends on what age group they are, what is their gender, what is their physical activity levels. Okay, there is no one straightforward answer, but if it is an adult, you will require at least 2,000 kilocalories, healthy calories. If you eat less than 1,500 kilocalories, please take multivitamins. If your calorie intake is less than or equal to 1,500 kilocalories, please take multivitamins. Okay. 2,000 kilocalories, why we say is a healthy balanced diet of 2,000 kilocalories will fulfill all the nutritional requirements without deficiency. 2,000 kilocalories, healthy calories, not the junk food, healthy balanced diet, breakfast, lunch, dinner, healthy balanced diet of 2,000 kilocalories is sufficient to fulfill a human being's entire nutritional requirement, micro minerals, vitamins, macro minerals, macronutrients, everything. So far, is it clear regarding the discussion of? No, an adult can go to 1,500 kilocalories. They can, based on their body statistics, they can. But if you come under this category where you are eating less than 1,500 kilocalories because you are on a weight loss mission, or because based on your body statistics, this is what you require. Okay, if 1,500 kilocalories is what you require for your body. This is again in terms of calories. Vitamins and minerals don't have calories. Remember that. So your body may be getting neglected from the vitamins and minerals point of view. So that's why if you're eating less than 1,500 kilocalories, definitely make sure you are consuming your multivitamins as well. Or based on your nutritional deficiencies, don't just blankly go and eat multivitamins. Get the blood work done. Find out what nutritional deficiencies you suffer from, and based on that, get a prescription done for correcting that. That's the best way ahead. So far, is it clear to all? Next topic is thermic effect of food on page number 144, I guess. 143 or 144. Please mention the page number. Thermic effect of food. 142. So this is a third category of energy requirement. It is how you estimate here the total energy requirements to provide thermic effect of food, that is heat from the food. Okay. And there are specific thermogenic food. One minute. Yeah. Am I audible now? Yeah. So thermogenic food means, break down the word thermo, heat, genic, create. Okay. Heat creating food. All your meat, dairy products. Okay. They are meat creating. Anything that is, they are heat creating. Anything that is rich in fat, heat creating. Okay. Because to break down this, specifically a fat rich food, to break down fat, a lot of energy is consumed from the body to break down the fat. Okay. So for that, naturally, your body's metabolism will be higher. Your body's metabolism will be higher when you eat thermogenic food. It is creating more heat in your body as a result of digesting difficult to break down food. Difficult to break down food does not mean bad food. Okay. Difficult to break down food means like protein is also very difficult to break down. Fat, good fat, healthy fat is also difficult to break down. Okay. Difficult to break down means in terms of metabolism. It takes a more time and effort from your digestive system to break it down. So the more the time and effort is utilized by the digestive system to break down the food, more heat is generated. So naturally, thermogenic food is going to increase your basal metabolic rate, BMR. Okay. So answer this question: will non-vegetarians or vegetarians in a healthy body, in a healthy body, non-obesity body, no underlying disease condition, who will have a higher basal metabolic rate? If you have non-vegetarian food on a daily basis, who will have a higher metabolic rate? Is it the non-vegetarians or the vegetarians? It is going to be the non-vegetarians, because non-vegetarian food inherently are thermogenic food. All the meat, all the dairy products, all the meat are inherently thermogenic food. So if you consume meat on a daily basis, in a healthy portion, okay, in a healthy portion, and the healthy meat, the lean meat, okay, not the red meat. Don't consume red meat on a daily basis. It will lead to cardiovascular diseases. Okay. Poultry can be, you can have poultry meat on a daily basis. It's completely fine. So having healthy portion sizes of non-vegetarian food on a daily basis, naturally your PMR rate will be higher because it's creating more heat in the body. Non-vegetarian food will create more heat inside the body as a result of its metabolism. Okay. TEF stands for thermic effect of food. Okay, it is the rate at which the body is metabolizing the meal. Okay, so 20 to 30% of the energy is required to break down protein. Okay, fat 0 to 5% because the fat content in the food is also very less as compared to carbohydrates. Okay, thermogenic effect of food, thermogenic effect of fat is higher, but in a diet, fat will be lesser. Reason being, the utilization of fat, the amount of fat utilized is very less. Okay, the amount of carbohydrates utilized is much higher. That's why carbohydrates has 5 to 10%, fat has 0 to 5% of thermic effect. Okay. The resting energy expenditure. So food, when you eat food and when you breathe in, you get oxygen and food. These are the components required to produce heat in the body. You require oxygen, you require breathing, you have to respire. Okay, for oxygen to be taken up by the cells and to release heat. Okay, oxygen is required. Along with that, food is also required to break down the macronutrients and give heat. Okay, so all the organ tissues, all the cells, okay, organ tissues have cells. All these at cellular level, oxygen is required. At cellular level, your carbohydrates, your proteins, your fats are required at the cellular level. Okay, it's not just the organ level, at the cellular level, these things are required. Oxygen along with the macronutrients is required to create heat. Okay, this heat is created as a result of ATP that is broken down in the mitochondria. Okay, ATP is the energy producers. They create so mitochondria is the energy producers in the cell, powerhouse of the cell. So they create ATP, and ATP is used to create energy because ATP has to be broken down. Here ATP stands for adenosine triphosphate. T means tri, 3 phosphate ions are there. ATP has to be broken down from triphosphate to diphosphate. Adenosine diphosphate, adenosine triphosphate to adenosine diphosphate. So 3 phosphate ions, one of them that will break down and it becomes ADP, adenosine diphosphate. So when this breakdown happens, that's when carbon dioxide, heat, hydrogen, nitrogen, these things are released. Okay. So energy is released when ATP is broken. Okay. That is the reason why you call mitochondria the powerhouse, because they produce ATP. ATP is released into the cells, into the system through mitochondria. Okay, so ATP, mitochondria are the ones that can produce ATP, and ATP is required for energy to be released. Breaking the ATP is required for energy to be released. Okay, so these things happen even if you don't take any activity. These are involuntary. So from an involuntary point of view, these things are happening even when you're resting, not doing anything. This breakdown of ATP will happen. It's not that you have to run, you have to do a physical activity for the ATP to be broken. ATP will be broken even when you're resting. Okay, when all the other body or major organs and tissues are functioning, ATP is getting broken down. So that is your resting energy expenditure or basal body metabolism. Is it clear to all, this particular slide? Coming to the factors that affect your basal metabolic rate. First is your body composition, which means the total basal energy requirement. Okay, per unit of your body weight is higher when muscle tissue is in higher proportion than the in the total body weight, which means lean muscles, if you have more lean muscles, when we do the fat to muscle comparison, does your body has more fat proportion or does it has more muscle proportion? So if it has more muscle proportion, your basal metabolic rate will be high. If it has more fat proportion, your BMR rate is lower. Okay, so here BMI will not play any role. Body mass index will not play any role. So because people who have high lean muscles tend to have more weight. Okay, people who have more lean muscles, if you take 1 pound of muscle and 1 pound of any fat, okay, 1 pound of muscle and 1 pound of any fat, can if you can imagine a situation, which will look larger, 1 pound of fat will look larger or 1 pound of muscle will look larger, if you can imagine a situation. It's the fat that appears larger. The weight of 1 pound of muscle and 1 pound of fat is same, but the appearance, okay, the square feet that 1 pound of fat will consume is much larger as compared to muscle. Okay, so that's the reason why a person who is lean have higher muscle mass will have definitely higher BMR as compared to a person who is obese and who has high fat mass. Okay. So that is about body composition. When the body is composed with more muscle, high BMR is there. Yes, high BMR is good because even if you stop exercising or stop doing a physical activity for a week or so, you will not put on weight because to maintain the lean muscle, your body has to stay at high BMR. High BMR is good for weight management. If weight management is your goal, high BMR is good. For a person who is feverish, who is suffering from infection, who is suffering from AIDS or TB, high BMR is not good because the body goes into a state of catabolism. Okay, body eats its own self to maintain its involuntary function. Okay, so a high BMR is always good. It is subjective. Is the person suffering from any catabolic state? In that situation, BMR has to come a bit low. Okay. Otherwise, if you are on a healthy life track in a healthy lifestyle, high BMR is good. It will keep you away from cardiac diseases. Okay, weight related issues, lifestyle related issues. Gender, as we all know, we have discussed earlier, males of any age group and will definitely have higher BMR rate as compared to females. The reason being, women have more adipose tissue. Adipose tissue means fat tissue, fat cells, as compared to men. Okay, so their body comprises more of a naturally women's body should have a higher fat composition because it produces healthy dose of hormones. If a woman's fat composition falls below normal, she will become infertile. Even at the age of 25, 30, okay, if a woman focuses more on building muscles and not maintaining the healthy fat level, she will lose her hormones, she will lose her periods, okay, she will suffer from infertility. Okay. Age. So when the age progresses, does the BMR fall down or does it increases? It will fall down. Your BMR rate goes down as you progress in age. So old age people, senior citizens, they have a very low BMR. Body size and the surface area. For example, a tall, thin person will have a greater surface area than an individual who has the same weight but who is short and fat. Okay, but who will have the highest BMR? The tall, thin person or a short person who is fat but has the same weight? Yes, it is a tall, thin person because the surface area, the tall person's body surface area is slightly higher as compared to a short person who is fat, has the same weight, but the body surface area of the fat person is lower as compared to the tall, thin person. So as soon as the body surface area increases, okay, the heat lost from that surface area is also there. Okay, you have to consider that also. Okay, so the heat loss will be also more in the tall, thin person as compared to a short, fat person. Both of them are of the same weight, but the tall, thin person's BMR will be higher as compared to the short, fat person. Then sleep. If your sleeping hour is less, your BMR falls. Okay. If you sleep for at least 7 to 8 hours sound sleep, your BMR will also pick up because majority of the fat burning because of BMR takes place during your sleep. Okay. BMR rate is quite high when you are asleep. Okay. So proper sleep, if your sleeping hours is less than 10% or 20% than the normal sleeping hours, your BMR will fall. Then body temperature. When you are feverish, when the body temperature is high, your BMR will be high. When the body temperature is low, or if you're suffering from hypothermia, okay, in cold seasons or winter seasons, people suffer from hypothermia. The basal metabolic rate falls down. So based on that, it's the seasons. Okay, if we take the seasons of summers and winters, based on the body temperature, which season do you think is easier for you to lose weight? Yeah, it's the hot seasons, it's the summer seasons, easier for you to lose weight. Next is your endocrine glands. People who suffer from thyroid issues, hypothyroidism specifically, when you do not produce enough amount of thyroid hormones. Drinking hot water before meals will create more digestive juices, which can aid in digestion. Okay, it necessarily will not increase your BMR directly, but it can indirectly increase your BMR. Okay. Hypothermia means the body temperature falls below normal. Hypothermia means body temperature is falling below normal. When your hands and feet get cold because of lack of blood supply, that is hypothermia. Endocrine glands, coming to the endocrine glands, thyroid issues, hypothyroidism, that will reduce your BMR rate. Increased secretion of growth hormone. Increased secretion of growth hormone can increase your BMR rate. The more growth hormone secreted, the more will be the BMR rate. Reason being, growth hormones is required to maintain your lean muscles. Growth hormones are required to maintain the lean muscles. So growth hormones, like increased secretion of growth hormone, will lead to increase in BMR rate. There is no average BMR. The BMR is based on a person's height, weight, age, gender. Okay. So if you want to check a normal BMR, healthy person's BMR, table may be allowed, maybe available. You can just check that. Age group wise, gender wise, a healthy BMR range will be given that you can check. In every age group, the BMR range differs. Pregnancy, by the first and the second trimester, the BMR will increase, but later on, by the last trimester, the BMR rate slightly falls down because the digestion has decreased. Digestion decreases because the body requires more nutrition. The process of digestion decreases a bit, it slows down a bit. Okay, so the BMR also falls down in the later stages of pregnancy. But in the first two trimester, during pregnancy, BMR rate increases by 5%. Okay. State of nutrition. If you have been starving a lot, okay, not eating food properly, starving, depriving yourselves of calories and nutrition, your BMR rate falls down. And tomorrow, when you start picking to eat up, your BMR rate will not increase immediately. So that's why it is easier for you to gain weight than lose weight. Okay. But also your body has its own compass. Okay, the body inherently, everyone's body inherently has its BMR compass. As soon as you start eating more and more calories, initially your BMR will increase. Initially, if you're healthy right now, you slowly start taking more calories. Initially, your BMR will increase. Okay, but BMR will not always keep up with the increased calories. That's why people tend to gain weight after. You will not gain weight within 1 or 2 days. It takes weeks of overeating and all for to gain weight. Okay, so why you are not gaining weight within the first few weeks when you started taking more calories? Because body has an inherent compass to increase the BMR along with the slight increase in the calories. That's why initially you will not put on weight, but slowly when the overeating surpasses the BMR compass, that's when you start seeing weight gain. Okay. That environmental temperature, lowest metabolic rate is observed in the environment that has a temperature of 26 degrees Celsius to 75 degree Fahrenheit or 75 degree Fahrenheit. So in this situation, if you are living in in an area where temperature is around 26 degrees Celsius or less, okay, naturally, usually the hilly areas and all, okay, hill stations and all. So there people will naturally have a slightly lower metabolic rate as compared to people who live in the coastal areas, humid areas. Okay, they will have a higher BMR. Smoking. It is seen that in habitual smokers, okay, BMR is increased by 10%. This is one of the reasons why in modeling industries and all, people don't smoke because out of the addiction to smoke, but they smoke to maintain their weight. Okay, it's a very wrong method of losing weight because smoking increases your BMR by 10%. Okay, but using smoking as an excuse to maintain weight or to reduce weight is a wrong choice of lifestyle. Okay, but it is also seen that as soon as you stop smoking, as soon as a person stops smoking, they will start gaining weight. Okay, so smoking increases the BMR, but it's not a healthy increase in long term. Genetics, BMR completely depends on the genetics also. Some people are blessed with naturally high BMR, okay, by family. Others have a low BMR. It is transferred. The BMR rate can also be transferred from family to the next generation. Psychological state, when you are stressed or in any situation when the body is getting a lot of epinephrine. Epinephrine is secreted by your adrenal glands. Okay, when you are scared, when you want to run away, or when you are in a state of fight. Okay, you are always on defense. You are always anxious. Okay, you are stressed, anxious, and you suffer from anxiety attacks. Okay, frequently you suffer from anxiety attacks. Always stressed. In this case, your BMR increases. Okay, because in all these situations, more epinephrine is secreted in your system. Epinephrine increases your BMR rate. Then certain drugs like nicotine, caffeine, that can also increase your BMR rate. Diseases, fevers, cancer, burns. Okay, these are some certain diseases in which the BMR rate increases.